My name is Zach Wily. My talk is titled Changes. I'm sorry I don't have the song playing. I should have done that. I'm going to be talking a little bit about our engineering team, our development methodology, and the life cycle of a bug as it enters our system, makes its way through support and up to engineering, and how it gets fixed and then pushed back out into production. So first off, a little bit about me. I've been at Instructure for 18 months now. I've been in software development for more than a decade. And I come most recently from Mozy, an online backup provider. I was an early employee there, and I was responsible for, I led the team that developed the large storage system that stored everybody's backups. You can blame me for the Panda. I'm not going to tell the story now, but if you're really interested in where the Panda comes from, then catch up with me sometime after. So a little bit about the team. We have 11 engineers now, and we're hiring, so please send resumes to jobs@instructure.com. We really need to find more good people. Most of our engineers actually come from Mozy as well, and I like to believe that they followed me to Instructure, but I think the truth is that they followed Josh to Instructure, since he was also at Mozy. So either way, they bring along some really great experience building a large web application from 0 to millions of users. And one thing you should know about this team, Canvas is written in Ruby on Rails, and our team has very deep Ruby on Rails experience. And in fact, a lot of our engineers have been using Ruby on Rails since before it went 1.0, which was in 2005. So we are domain experts in Rails. There's a ton of other stuff that we're experts at, as I tried to capture in this tag cloud. The very experienced and very talented engineering team. So first I want to talk a little bit about a traditional software development cycle. Normally there's several different phases. You start with the requirements phase. Once the requirements are defined, then you go into the design phase where the product is, what you're going to be writing is defined. Then you throw everything over to the engineers, and the engineers spend a long time writing a bunch of code. And then they throw that code over to the QA team who does verification and quality testing on the code. And then after the release, then it goes into maintenance mode. This development cycle is traditionally called Waterfall for what I hope are obvious reasons. As you can see, the product sort of falls down each phase, sort of like a waterfall in this picture. I hope it's obvious that we don't really like this style of software development. There are a lot of disadvantages to it. And for the most part, forward-looking software companies are moving away from this process. Some of the problems with it are requirements up front. This process requires you to know exactly what you want to build at the very beginning. And a lot of times you don't know that. A lot of times you won't find out that something's going to work or isn't going to work until you're in the coding phase. And then the requirements have to change, the design has to change. So this sort of style is very rigid and prevents you from making changes. Another problem with it is it takes a long time. Each of these phases can take months. So your release cycle may go maybe 6 months or maybe a year between releasing different versions. And in Instructure, we don't like that. We like to get code out to our customers as quickly as possible. So about 10 years ago, and in fact almost exactly 10 years ago, 17 gentlemen gathered together, and they gathered together here at Snowbird, which is kind of a strange coincidence. They got together and wrote what's called the Agile Manifesto. And in the Agile Manifesto, they captured some values that they think are very important when it comes to software development. Individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. So there's value in the items on the right, but we value the items on the left more. And the Agile Manifesto has led into what are called agile methodologies, which provide more flexibility and better products for end users. So our development cycle looks a little bit more like this. We start with a backlog of features and bugs on the left, and those are fed into a 2-week development cycle. And you can see there's a circle here, and around the circle are design, code, and test. And the circle represents the fact that these are all ongoing processes, and they're all happening all the time. Something isn't designed and then thrown over to the engineers to code, and then thrown to QA to test. We design a little bit, we code a little bit, we test a little bit, and we do it over and over again until we have the feature that we want. There's also another loop at the top right where we incorporate daily feedback. So we have daily meetings where we find out, where we make sure that everything that we're doing is on track and that people haven't run into roadblocks that are going to slow them down. And at the end of this cycle pops a new version of Canvas with bug fixes in it and new features in it. So all this enables us to release quickly. And I'm going to talk a little bit more about that later. But now I want to talk about what happens when a bug gets reported to us. Okay. So Mary Livingston, she's an admin at Howard. She reported this bug a few weeks ago. Unable to update term details. Changes are not saving. Okay, that sounds bad. She provided some more details. Terms don't seem to work at all now. I have a turn set up. I can't save the changes. Okay, that sounds bad. We better fix that. Not only did she provide a pretty good explanation of what was happening, but she also included all these great screenshots, which showed step by step exactly what was happening. And this is fantastic. A lot of Canvas users also provide us with screencasts, which helps a lot when we're trying to figure out what's gone wrong. So if you're doing that, thank you. It's very helpful. Keep doing that. So Mary reported this bug. It went into the support queue, and Travis, one of our new support engineers, picked it up, and right away responded to her, "Hey, we've received your ticket. We're going to begin investigating." And then a little bit later, he had managed to reproduce the problem and told her that he's escalating it to engineering. So he escalates the ticket to engineering and includes some more details on what's gone wrong, and in fact made a movie himself of what was happening. In this case, it was a little bit unnecessary since we've already had a lot of detail, but still very helpful for the engineers. So every week, we have an engineer that is on call and responsible for all of the tickets that are escalated to engineering. And the engineer this week was BJ. And it's not actually a random thing every time. That's kind of deceiving, but that would be fun, wouldn't it? So BJ, he did a little investigation himself, confirmed the issue, and filed a ticket within our engineering ticketing system that said, hey, we need to fix this. And this ticket went into the prioritization phase. So prioritization, how do we prioritize tickets? The first thing we look at when prioritizing a ticket is severity. And severity normally means, okay, how many people is this affecting? Is there a workaround? And things like that. We also look at the number of complaints. So if it's maybe not that severe an issue and there's an easy workaround for it, if a lot of people have contacted support about it, then we'll raise the priority on it. We also look at the age of an issue when we're prioritizing tickets. So even if it's something that's not that serious, hasn't been complained about by very many people, but it's been around for a long time, then we will raise its priority. In this case, the ticket we classified as a high priority, since it affected the ability for administrators to limit access to course content based on dates. So you couldn't say, I want students to only be able to access content the week before and the week after a term starts. So we said this is a high priority issue. Now at this point, the question that usually comes up is, okay, when is my bug going to be fixed? Most of our support tickets are responded to and closed within 24 hours now. This is largely thanks to our recently grown support team. And issues that are escalated to engineering might take hours or they might take weeks, depending on the priority. So it's very hard to say from a single ticket, oh, this is going to be fixed today or tomorrow or next week, because there's a very wide variance between tickets and when engineering is able to resolve them. As a side note, if you think that the issue that if you filed an issue and it's been around for a while and you think maybe it's been misprioritized, feel free to update the issue and ask support for more details, and we can reevaluate at any time. We're also going to be doing something new that we just started in the last couple weeks, and we're going to be updating tickets while they're in this waiting phase, waiting for engineering to do the fix. We're going to be updating those periodically with information, just so that you know, yeah, we haven't forgotten about this. We know this is still an issue. It's still going to be fixed. And if we have an ETA at that time, we'll tell you, oh yeah, this is going to be fixed in August, or if we don't know, then we'll say we don't know. But in the past, some people have been a little bit frustrated from not knowing, okay, my ticket was escalated to engineering, now what? But we're fixing that, and I hope that helps keep the feedback loop open on the issues that you filed. So this ticket was filed as high priority, and we decided to fix it immediately because of its priority. And I'm the VP, but I am a very hands-on VP, and I wanted to get my hands dirty on this ticket. So I decided to take a look at it and see if I could fix it. And it turned out to be a pretty simple problem. So I fired up my text editor, found the problem, fixed it. Great, yay for me, right? That's not the end of the story, though. Once you've fixed the bug, the engineer's job is not over. After I fixed it, I had to write a test. Now, there are several different kinds of tests that we write for Canvas. The first kind of test is a unit test, and a unit test is a very targeted piece of code that tests another piece of code. An integration test is a test that tests how several different modules of code work together, so how they integrate. But the most exciting kind of tests that we write are our Selenium tests. And Selenium tests actually run within the browser, and they simulate a user clicking on buttons in Canvas just like you are through your web browser. And they test the entire Canvas stack through the web browser down to the web server and down to the database. So these are very comprehensive tests, and they're also the trickiest tests to write, but they test the most things. So in this case, I decided to write a Selenium test because part of the bug was something in JavaScript. So I wanted to write a test that would prevent this bug from ever popping up again. So what I have here is a video that I made of all of our Selenium tests running, and you can see the interactions that it's making with Canvas and the things that it's testing. But the Selenium tests normally take about 30 minutes to run. I've compressed this video into 1 minute, so it goes really, really fast. At the very beginning of the video, you'll see the term details. You can see a screenshot of it here. You'll see my fix, or the test that I wrote for this fix. And it's going to flash by really fast, so watch for it. Okay. Oh, there it is, right there. You see it? Okay, it's done. So it really takes a couple minutes and when it's not running sped up like this. So it's testing other things like enrollments. These are some plugin settings. It's tests some things in the wiki. Quizzes, there's quite a few tests around quizzes actually. One of the interesting things about these tests are that they actually run at least several times a day. In fact, before any code is checked in to our source code repository, all of these tests are run on that code. So we can be pretty confident when we're checking stuff in that we haven't broken things in the past. And as we get more and more mature and write more and more of these tests, then there will be lots more coverage. Mike?
Yeah. I don't mean to be a challenging question, but is this also run at the time where an initial new feature is implemented? Because it seemed like if that could be done, then maybe it wouldn't have been a bug in the first place.
Yeah. So part of the problem is we don't have tests written for everything right now. It's just recently in the past few months where we've set a policy in engineering that no new code gets checked in without tests accompanying the change that the code is making. So as we go forward and as we write more and more code, the test coverage is going to get greater and greater. And the goal is to not be ever introducing new bugs because everything is so well tested by the automated tests. And these automated tests are critical to us achieving our fast release cycle. There's no way that a QA department could test the entire Canvas app in the 2 weeks between doing releases. So we have to rely on our automated tests, doing as much testing as we can, and the QA engineers filling in the gaps where automation doesn't make sense. Okay, so I wrote a test, and we're still not done yet. The code is not accepted into our source tree until it has been through peer code review. And peer code review means that another engineer, at least one other engineer on the team, reads the source code, all of the changes that I made, and signs off on it, says, hey, this looks good to me, sees that I didn't miss anything, makes sure that I included a test. In this case, 2 engineers reviewed it, Cody and Brian. They both said, looks good to me, so that's good. These are messages from our automated testing system saying, hey, I ran all the tests and they all passed, so I sign off on this, it looks great. And then I'm done. At that point, everybody has signed off on it, and the code is then submitted into our source tree. And pretty soon after, it shows up on GitHub because, as you know, we're open source. So everything that we do shows up on GitHub pretty soon after we do it. And this screenshot is actually from GitHub. At this point, we go back to Mary and say, hey, Mary, we fixed the bug. It's not released yet into production, but it will be soon. And yeah. So the next question is, when does it get released? Well, like I mentioned, we're on a 2-week release cycle. So every other Saturday, we release a new version of Canvas with all of the updates and bug changes that have happened in the previous 2 weeks. So we had a release July 23rd, and we're going to have one this Saturday, August 6th. The week leading up to a release, we put the code on what's called a staging environment. And the staging environment is kind of a buffer environment between what we're doing internally and production, because we want something to live in a quasi-production environment for a little bit, just so we can do some sanity testing on it, so QA can do some validation on what we've done and make sure there aren't any surprises. The staging environment lives at staging.instructure.com. This is actually a live environment, and it uses the same databases as Canvas Cloud. QA does their validation there, and anybody can use it. Any of you can go to staging.instructure.com and log in and see if you know of a new feature that's coming up. You might see it on staging. There is one caveat to that: anyone can use it. If your institution uses SAML or CAS authentication, then you won't be able to use it through staging.instructure.com because it's not going to send you to your authentication provider. So if that's the case and you want to use staging.instructure.com, just let us know and we can make a tweak on your account that will let you use it. Okay, so we're ready to deploy. All the deploys happen on Saturday mornings at 7 a.m. Mountain Time. They happen with no downtime, no versions, and no hassle. And this is part of the cloud, one of the benefits of the cloud that Josh talked about earlier today. Our last release happened July 27th. There was no downtime. And a couple of the things that were added in that release, one of the features was we added enrolling people by username. This is for the case where you might do SIS imports of users and not require email addresses for all your users. And in that case, our previous manual enrollment interface required you to use an email address. But now you don't have to. Now you can use login IDs. Another feature we added was for account admins to be able to masquerade as users. So if you're an account admin, then you can become a user on your system. And this is something that Devlin demoed this morning. And there were also 12 bug fixes in Saturday's release. So then we contact Mary, and this usually happens either on the Saturday of the release or early in the next week after. We say, hey, Mary, your fix was released. Thanks for reporting it, and then the issue's closed. So just as a little recap, the issue is reported, goes into the support queue. If it turns out to be something that needs to be escalated to engineering, support will escalate to engineering where it enters triage and prioritization. And then is the wait period, where depending on the priority of your issue, it waits for the engineer to fix it. And then after the engineer fixes it, then it's released. And this is a picture of a happy panda because his bug got fixed. Okay, so now I think we have about 5 minutes for questions. So.
What about non-cloud, like an UEN, or how do they release it?
Yeah, so what happens for UEN, we provide packages for UEN the Monday after we do a release to Canvas Cloud. And then they are welcome to upgrade their installation at their convenience. Mike?
Am I right in understanding that if it's a really critical bug, you can also push them out? You don't have to wait for the 70-day
Right.
cycle.
Yeah, so Mike's question is, if it's a critical bug, can you push it out without waiting? And absolutely. And we'll do that when something critical comes along. We call that a hot fix. And it's absolutely one of our processes.
I'm curious about, I understand this process for bug fixing, but like new feature requests and then also like user feedback and how that gets incorporated into the overall roadmap.
Yeah.
Do you have processes for that?
Yeah, so new feature, the question is about user feedback and new features and where that fits into this process. I would recommend attending Brian Whitmer's session. He is the VP of Product, and he actually handles, okay, what are we going to be building in coming months in Canvas? What new features are we going to be adding? And him and his team decide, okay, what new features are going to be added? And then at that point, when the month comes up where it's going to be added, then it goes to engineering and say, okay, guys, we want this feature now. So I recommend you attend that session. Okay?
What are the issues filed on the GitHub issues listed into your ticket prioritization?
So the question is about the issues filed on GitHub. GitHub has its own issue tracker. So that's actually a really good question, which we're trying to decide on the answer to right now. What school are you from?
Ontario College of Art and Design.
Okay. Yeah, we've had a lot of activity recently on the GitHub tracker from some people some engineers at University of Washington have been doing a lot of accessibility testing and things like that, and they filed a whole bunch of issues in GitHub, and we're still trying to decide how those are going to be handled as part of our normal process, because this is a relatively new thing for us, but yeah, we're working on it.
You seem to have a pretty good handle of making sure that bugs don't get reintroduced when you're fixing code, but let's say someone does get through, do you have a process for how you roll back to unbroken code, I guess?
Yeah, so the question is, how do we roll back if one of our deploys is broken? Is that right?
Yeah.
Yeah, so part of our deploy process is we don't remove the old code that's deployed when we deploy. In fact, we keep the past 20 releases every time we do a new release on the application servers. So when we deploy, we do a lot of sanity checking after the deploy is done, and if we see that anything's wrong, then we just have to run one command, and it will actually go out and flip the switch to point back to the release that was from the most previous release. Any more?
You mentioned the kind of tests that you guys write. Which of any of those tests are incorporated into the actual Canvas code base?
All of them. Sorry, the question is which of these tests are incorporated into the Canvas code base, and all of them are. In fact, you're welcome to go to GitHub, github.com/Instructure, and go to the Canvas LMS project, and if you go look in the folder called specs, I think it's spec or specs, one of those two, you can see all of our tests.
Does the open source version follow the same 2-week cycle?
Yeah. So the open source version it's a little bit different. We don't delay releasing anything to the open source version. The open source version has, in the Git repository, there's a stable tag. And every time we push code to our staging server and that gets released into production, we update the stable tag in the open source version to say, this is what we're running now, so we think this is relatively stable. But the master branch on GitHub is identical to our master branch internally. We don't hold very much back. Anybody else? Okay, no hands went up. All right, thank you, everybody.